specialist consulting company. I've been doing DB2 for 20 odd years now, and recently started working with 10.5, both with customers and doing some research and development within our own organisation. So I'm just going to try and outline a few of the issues that I think exists with 10.5. I need to ask you, the audience, a couple of questions first, really, just to gauge where we're going to go with this. So if you could just give me a show of hands, how many people are actually aware of blue acceleration, in particular column organised tables? Okay, it's pretty much half. I'll do a couple of quick slides, very, very simple, just to make sure we're all on the same page as far as that goes. How many of you are actively using it, either on a client site or on your own site? Getting into a quick show of hands? Not so many. Okay, so I'll spend a bit of time just looking at the components of blue so that the tests I'm running later on make sense. And how many of you actually hit a performance problem with this? How many of you actually found that you're looking at the access path and looking at the CTQ operation and things and thinking, what's going on there? So it's just a couple, 3 maybe. Okay. Right. I've also got to just own up a bit before I get started so that you're not disappointed. I'm not going to give you an actual solution at the end of this. I'm raising what I think is an issue, possibly a problem, I don't know, but you're not going to get to the final slide at the end of 40 minutes or whatever and have me say, and the answer is you run this query against the sysIBM what the hell's going on view, and it tells you what's happening. So if you're hoping that you're going to listen to me drone on for 45 minutes and then I'm going to present you with an answer, I'm not going to be able to do that. I'll give you a few suggestions, but if you don't want to do that and want to go get a coffee instead, I wouldn't be disappointed if you call it a day here. And finally, one disclaimer. I've got to just say I don't want to sound like I'm knocking blue. I'm a big fan. I think it's terrific. If I can get any of my customers to stand still for 5 minutes, I'll bang on about it endlessly to them. But no software's perfect, so I think there are issues with it, and I just wanted to explore a couple of those. So that's my agenda. I will do a very brief couple of slides, very, very simple, on what blue is. We'll look at the components. I'll outline the test scenario that I put together, and basically I just got 4 queries. Imagine it to be named Q1 to Q4, and it's a like-for-like comparison, so I'm trying to run it against a purely row-based scenario and then run it against a mixed workload, same structures, same data, and try and compare the metrics and try and see where the performance issues might be. So, like I say, very, very simple. Look at the way blue works. If you imagine a table something like that, 20 rows, 14 columns, whole bunch of data, and you're just going to run a very simple query. It's going to extract a subset of the columns based on a simple predicate like that. Well, if you're doing it row-based, you'd be getting that chunk of data back. If you use column-based, you can reduce that. Okay, row-based, column-based, that's it. It's getting you less data back. It's also fairly aggressively compressed, so it'll be even less I/O, even less consumption of your memory. Add into that a number of hardware capabilities, which I'm not going to talk about here, but you probably heard about this week, and you can anticipate some very rapid analytical processing of large volumes of data. So the actual components, if you create a table, whatever means you use, I'm just using a like, so I can build a columnar-based version of an existing row-based table. The important bit is just get that organised by column in. That's all you've got to do. By whatever means, if you create a table and the organised by columns in there, or if your database is enabled by default to use Columnar. But using that particular statement there, so that's the set of columns that are in the row-based table. That's the same set of columns I'll end up with in the columnar, so the structure will be maintained. And And having run that, you'll end up with two tables. So you'll end up with the contract_blue table that you asked for, and you'll end up with this synopsis table that you didn't ask for. They're very easy to find because they always start SYN and they always end with the table name that you supplied. And what's in the synopsis table is 2 columns for every column in your source table. So it just defines the range. It's got the column name with min and max appended. And you can see at the end there's also 2 further columns, TSN min, TSN max. TSN stands for tuple sequence number, and it's really just a row identifier. So what's happening here is we're keeping ranges of data so that we can identify the rows that we specifically want. If you look at, I'm sorry, that's really quite hard to read, isn't it? That is the contents of the synopsis table here, but if you can see, there are some realistic ranges for the contract numbers. So if you chose a contract number 472347, it would find that first row and say, right, that's where the data's stored. It will go to the tuple sequence number and it will go and find those row IDs. Less useful, if you look there, you can see the customer ID, min and max. It goes from 1 to 199 all the way. So if you chose to write a query using a custom ID as a predicate, this would be no use to you. It's just going to find every row has got that. So the way the synopsis table is built and the contents of it is very much, well, it's entirely defined by the way you've loaded the data. So you have to be quite careful about the order of the data that the order you've put the data in when you load it, if you want the synopsis table to deal with the queries you're going to be throwing at it. It's said that you don't have to have indexes in column organized tables, but you can create unique indexes. So you could put a primary key in there if you wanted to. So if you look at the indexes that have been created, you'll find your primary key if you've chosen to build one, and you'll find this CPMA index. Again, you have no choice about that. It will be built for you. You don't have any control over what's the structure of it, what's in there. CPMA stands for CDE page map, and CDE stands for Columnar Data Engine, another one of those compound acronyms that IBM are very fond of. But you'll find that index there, and you'll also find, of course, that there's a CPMA index for the synopsis table. Synopsis table is just another columnar organized table. Every column organized table is going to have a CPMA index. And if you looked at the access path for a query that's using this new contract _blue columnar organized table, you'll see a CTQ boundary. The CTQ is the bit where it stops being columnar and starts being row-based again. So the columnar engine, the columnar processing will access columnar data and will then pass those results up to the row-based processing to sort of finish off, if you like. So that's the transition, and the sort of rule of thumb in theory is the higher you can get that CTQ boundary, the better it's going to be because the more columnar processing it's doing. But what you won't see necessarily is a lot more information than that. So all it's telling you is it's done a scan of a code table, columnar table, called contract blue, but you wouldn't necessarily see anything. You won't, for instance, see that it's used the CPMA index. You wouldn't see that it's used the synopsis table. That's just going to be under the covers somewhere. So, the issue. What if you go to the trouble of building columnar tables and then you find that it's not as sufficient generally, or maybe you've got 1 or 2 queries, maybe you've converted a whole database to columnar and most of your users are really happy, and 1 or 2 come back to you and say, you know what, my workload, my report, my Cognos report is now running worse than it was before. How do you find out what's going on and what the optimizer has chosen to do? How do you decode the access path? What metrics can you use to try and run that down? I mean, the thing about Blue is, and this is a quote from the IBM strapline, it's very simple. It is load and go. You put it together very easily. You saw how simple it was to create a columnar table there. And it's terrific when it works as advertised. And to be fair, that's largely what happens. But I'm a DBA. I'm a bit nervous if I can't find something to let me know exactly what's going on under the covers. I want to put my finger on some statistics or see something. So I'm trying to explore a bit here what's going on beneath the CTQ boundary. So I've set up a test on our R&D environment. I just defined a simple set of tables. So you've got a couple of dimension tables there, not much data in those. I built a fact table in the middle and generated 5 million rows of random data. And then I built the contract underscore blue that we saw the create table for, statement for before. It's identical to contract, it's got exactly the same data in it, it just happens to be column organized. So if you're interested in DDL, then that's how the contract type was put together. Slightly more complex for the customer, but not much. It's got a few more columns in, but both you see organized by row. The original row-based contract table, and then I've created one column-based underscore blue like that and loaded it direct from contract. So it's got exactly the same data in there. And if you look at it in a sort of schematic fashion, it's that simple. Okay, the column organized table is actually sharing access to those dimension tables. So it is, I think, about as much like for like as I can possibly get. Sorry?
Why did you not create the lookup table, the customer, and the contract type as a column table as well? Of course, you will have a suboptimal plan if you have the dimensions in the row store.
Right, so the question is, why are the contract type and the customer, the dimension tables, defined as row organized, not column organized? I was getting conflicting advice about this, to be honest. Some people were saying that for a small table like that, you should be using row-based, it will be more efficient. Some people said, actually, you're better off turning a whole lot into columnar. What I've done is, towards the end of this, I've actually tried that as an experiment as well. I've tried converting it all to columnar, and I actually tried denormalizing it as well. So we'll have a look at those results when we get towards the end of the presentation. The actual tests will run using 10.5 Fixpack 4, fairly modestly configured Linux server, 32 gig of memory, 4 cores. And let me just show you the queries I'm using to start with. So I've got 4 queries. The first is this very simple 3-way join, and all you need to do is to change contract to contract blue in that, keep the same SQL, and it will be like for like. So it will go from purely row-based to a mixed workload just by changing that. See, not much in it, no aggregation or anything like that, fairly simple query. I probably expect that to run better in a row-based than in a column-based. The second one is a very high aggregation query, only using the fact table. So it won't be mixed workload, of course. When I change it to contract blue, it will be purely columnar. But this is going to look at a lot of rows and come back with a single row. So jury's out now. I'm not sure whether you expect that to be better row-based or column-based. The third one is a kind of, it's a more of a warehousey query, and it does start to use aggregation. So it's got a common table expression, still with that 3-way join in there. I've got contract blue there, but for the row-based, obviously I just have that as contract. And then you've got a query based on that common table expression, which includes some aggregation, max-min, got group, having by, and a sort in there as well. So a more warehousey sort of query. And then I've got a final Q4, which is the one that I would expect to be better in a column organized table, to be honest. it's got a range in there, which I think the synopsis table will be used for. It should be able to cope with the group by more efficiently. It's got some counts and so on. I'm hoping that's the one that will spring into life when we make it columnar. So I'm going to take those 4 queries. I'll estimate what's going to happen by explaining it and then just looking at the formatted output of the explain. And I'm going to use some table functions to look at the actuals. So I'll use monGetIndex to look at the index stats, obviously, monGetTable. And the actual execution metrics, I'm going to use monGetPackageCache statement. So let's have a look at what happened with that Q1. First execution, that's the SQL, obviously, that we've just seen, run against a purely row-organized table. And the estimated cost is expressed as time runs. That's the one I've taken from the explain. The other metrics are all taken from monGetPackageCache statement table function. So you can see a fairly high time run cost and a fairly high CPU cost. And there's an indication here that the entire table was read. I said 5 million rows of random data. Some of it I had to throw away because it was orphan data. So that is the entire contents of the table that's read there. And it's returned a fairly small result set from that. And reading the entire table, that's what the access path suggests as well. We just got table scans on each of the 3 tables, including the main contract table, the fact table, and you can see it used 14,017 time runs there. That's the bulk of the estimated cost. If you look at the monGetIndex, in fact, I've got a B4 row in there, which is because in order to get the deltas, you've got to run it once and then run it again after your query. So B4's on this. I'll omit it from the following slides because it just confuses things. But just so you know, that's how I'm getting the deltas. You can see there was no index activity at all, actually. That's because there's only that primary key defined. So I didn't think that was an entirely fair basis of comparison. So I put it through the advisor, this bit of SQL. It suggested an index, so I built that. And I've got a second execution here, which I've called row X for row-based with an index. And you can see it still doesn't use the primary key, but it has started to use this new index, scanned it, most of the data being already in memory, but a few physical reads. And that's what the explain suggested would happen. There you go, down the bottom right-hand corner, there's an index scan on the contract type IX. So if you go back to the actual, well, the estimated and the actual metrics, you can see for the original execution there was reading the entire table. It's now only reading about half the table for the same result set. So that's got to be an improvement. The estimated cost and the actual cost have dropped significantly. So let's try the same query against the column organized data and see if blue does anything for us. It's not an ideal query on paper for blue, but it's still processing 5 million rows, so we should see some improvement. Time runs are better, so it's estimating it's actually going to be significantly better. The actual CPU, better than either of the row-based executions, but it still scanned the entire table for the same small result set. Activity and wait times are both down. But you don't get much information from the access path. It still just says CTQ as a table scan. That's what I did. So you've got to try and work out what actually happened to make this more efficient. If we look at the index stats, what you can find is that it's using that CPMA index on the base table. They're all logical reads, which is ideal, of course. All the index activity is taking place in memory. but there's no activity at all on the CPMA index on the synopsis table. So it doesn't seem to be using data skipping. We can check that by looking at the data from MonGet table. You can see the number of logical and physical reads for the row-based versions there. And now have a look and see what we're doing with the column-based versions. First of all, the number's gone down significantly. So we're doing much less activity, both physical I/O and access to the buffer pool in the column-based version, but as you can see, it's not doing anything for the synopsis table, so presumably that just isn't being used in this example. So why is it better? Well, probably because everything is so compressed that it's actually getting everything back out of memory much quicker. It's only doing one scan of the table rather than the 8 that the row-based query did. It's exploiting its inbuilt CPMA index. The logical reads are lower for the column-based version because it's storing and retrieving data more efficiently. Remember, everything's compressed fairly aggressively and is staying compressed in memory as well. So I think that's why this one is more efficient. But you can only infer that from the figures you're seeing here with the logical and physical reads, I think. We'd probably get even better performance if the synopsis table was being used, but we think we can demonstrate fairly accurately there that it's not being accessed, and so there's no data skipping taking place. So Q2, let's have a look at that one. The Q2 is the single highly aggregated result set coming back from a scan of the entire table. I've left the figures for Q1 up there just for comparison. But if you look at the row-based version of Q2, estimated cost and actual cost, and compare that to the column-based version, the row-based version actually reads less rows, which is a bit strange. But the estimated cost is slightly better. The actual figure is much better. This is obviously performed far better in the column-based version than the row-based version, even though it's actually read a few more rows. As you'd expect, if you try and compare the amount of time spent in the columnar processing to the total execution time, it's now 100% in column. Well, it's probably 99.95 or something like that, but it rounds up to 100%. So it's no longer mixed workload, it's purely columnar. If you look at the index activity there, you can see in the row-based version it did actually use the primary key, and I had to get it all populated with physical reads, which will obviously slow things down. The primary key on the column-based version isn't used at all. The CPMA index is extensively used and entirely from memory again. Just got to be a good thing. The synopsis table index, the CPMA index on the synopsis table is now being used. One physical read, 36 logical. It's still fairly efficiently making use of its memory. It's taking a slight hit in terms of physical reads, but this is such a small table, such a small index as well, that you would hope that having used it once, it's going to end up effectively pinned in memory, and subsequent queries are going to be even better than this. But have a check of what's going on in the MonGet table. Row-based, lots of logical reads, 14% physical reads. The base table, 5% back from disk, but it's a much lower logical read figure. So it's using its memory much more efficiently, again, probably because of the aggressive compression. And we can now see that the synopsis table is being accessed as well. So we are actually doing some data skipping. So that's probably why this one is more efficient. The total CPU for the column-based is much lower, but the activity time suggests it's higher, but I'm not too bothered. As long as the total CPU comes down, I think that's probably enough here. And again, our logical reads are much lower for what is effectively the same piece of SQL but being run in a columnar fashion. So it's storing and retrieving data much more efficiently in that buffer pool. And now we're getting the benefit of using the synopsis table. So it's doing that data skipping, identifying ranges that it can avoid, just concentrating on the bit that we actually need. So let's try the Q3 one. So far so good. Columnar queries appear to perform better than the row-based one, even when we didn't really anticipate getting much benefit. Q3 is more of a BI OLAP type of query, and you should expect some benefit from Blue here, I think. Just to remind you, it's constructed around this common table expression. It's done a three-way join again, and then it's doing a select with some aggregation and other bits and pieces in there. So there's the row-based version of that. Estimated cost. That looks like we could expect it to be a lot better with a column-based version. The total CPU, it actually was significantly better. It only used about a quarter of the CPU of the row-based version. Buffer pages requested, much lower for the column-based version, and it hasn't had to invoke any prefetch to accomplish that. You can see the rose red is similar. I suspect that the higher figure for Columnar is down to the fact that it's using the synopsis table. Maybe that's being added in there too. I'm not entirely sure. I was surprised to see it drop to 23% for Blue activity. That seems rather a lot lower than I'd expect. So I'm not quite sure where the extra is being used there. But let's have a look at the index activity. I'll keep the last couple of rows and those actuals at the top there so you can compare to that. Again, the index activity shows the row-based version. Doesn't actually use the primary key. It can't make any use of that at all. Whereas the columnar-based one is able to exploit its CPMA index and is able to use pages that already exist in the memory pool for both the base table and the synopsis table. So that's all pretty good. That's probably why that's index activity is all happening in memory. That's going to help a lot. The metrics from the table themselves, well, the row-based one, 31% back from disk, and a fairly high figure there in terms of logical reads. That's going to slow things down. Column-based version gets all but 3% of its data back from memory, and a much lower number of logical reads from memory than the row-based version. And again, it's exploiting the synopsis table. You can see it's getting 32 pages back from memory, but there's some physical read, but it's such a small table that's pretty negligible. So this is all good. To varying degrees, the Blue features are being exploited. We can see now that it's using synopsis tables, we can see the CPMA index is being used in an efficient manner. The estimated and actual costs have been better in every version for the column-based version of the query. The question is, what do you do if the results are not better for Blue? What if they're worse? So let's have a look at Q4. Now this is the one that I thought would actually be better. It's written with Blue in mind, really. It's another BI OLAP type query. It's simpler than the previous one in many respects. It doesn't use a common table expression. It does invoke aggregation. It does require a slice of data, the contract number range there, so it should use the synopsis table. Let's have a look at actually what happened. So there's the row-based version. Okay, time runs, it's fairly low, Looks pretty efficient. CPU's quite high, but it's better than it has been before. But again, I wasn't entirely convinced that that was fair, so I put it through the advisor. Got a couple of indexes recommended, so I've applied those, and we've got a second execution then, ROX, where the indexes are actually now in existence. Timer-ons dropped right down. CPU's dropped hugely. It's obviously benefiting greatly from having these indexes in place. That's a pretty good improvement for very little DBA effort. After all I did was run the advisor, take those indexes, put them into place. I got the improvement. Much less buffer pool activity, no prefetches now that I've got my indexes there. The data's more specifically targeted, not having to scan through all these rows. So I'm quite pleased with that. And there you are, there's the access path proving that the index scan has gone from a rather clumsy use of a primary key to this rather more elegant index scan on the two tables and a nested loop join. So it didn't take a lot of effort, but the point of Blue is that it shouldn't really take any effort. It is load and go. All these indexes are built for you, and the synopsis table is built for you. It's all available without you having to do things like advisor and create indexes. So let's have a look at what happened to the Columnar version of the same query and see what Blue made of it. Right, so the estimated cost, even compared to the unindexed version, has gone up by about 500%. And it's about 2,000% of the one after you've got an index in there. But I think there's some evidence to suggest that timer-ons, the estimated cost is slightly skewed for column-based versions of the query. But even then, if you look at the total CPU, well, it was better than the unindexed version, but it's far worse than the indexed version. So what's happened there? Well, this is really the crux of my argument. When all's well and good, you don't need to delve into the innards of Blue to work out what's going on. If you demonstrate to a client or your users that converting a table to a column-based version will speed up their query by X%, they're unlikely to want a detailed examination of what's going on under the covers and why, and neither probably will you. But if the query takes longer to run when you're using Blue, where do you go then? Well, we've already had a look through what's going on in indexes and table metrics, so let's have a look at what's happened here and see if we can work out what's actually occurring. So you look at the index activity, query by query. You can see the initial results there for the unindexed version. All via the primary key, because that's all that's available. Low percentage of physical reads, but quite a few logical reads. That looks reasonably efficient, actually. Once you've got the index version in there, and you've got your new index, there's a higher proportion of physical to logical reads, but it's still a much smaller number of pages back from memory than the unindexed version. According to this, it still appears to be using the primary key too, although the explain contradicted that, but I'll let that go for the moment. So what did the columnar query do? It used both CPMA indexes. It ignored the primary key on the columns fact table, and it accessed all required data from memory. So like the previous three queries, it seems to access a much smaller set of pages and to have got them all out of memory, probably due to that terrific compression again. So let's take a look at the table metrics. Again, we'll do it query by query. So there's the unindexed row-based version. Large number of logical reads, only 1% back from disk. That's fairly efficient. Once you've got the indexes in place, you end up with a higher number of physical reads and a fairly similar number of logical reads. 41% back from disk. So you think probably that wasn't, oops, you think it probably wasn't terribly efficient. If you look at the columnar table access, as in the previous Q3 version, you can see the synopsis table is being used for data skipping. We know the CPMA index is used for the synopsis table as well. It scanned through that once. The CPMA index on the base table, again, small number of logical reads. Okay, it had to get 20% back from disk, but that's still a much lower number of logical reads than you've got for either of the row-based versions. And a relatively low percentage of physical reads there. So Q4 doesn't look any worse than the previous columnar versions we looked at, the Q1, Q2 and Q3. So why does it look worse in terms of CPU consumption, the actual metrics? Or are the metrics I'm looking at here the wrong ones? Maybe there are more ones more conducive or more specific to columnar data? Or are there any other options for looking into the CTQ operations?
Sorry to interrupt you, Mark. So the DB2 batch, say 100 repetitions or something also shows Q4 is performing. The elapsed time is much more than the, columnar elapsed time is much more than the row and row X, isn't it? So you have checked that also.
Well, right. The question is, if you looked at these same operations using something like DB2 batch, would you see the same worse performance for column versions than you did for row versions? I've actually got a slide right at the end, which I'm going to show you the figures for that. As I said at the start, those are the questions I haven't really got an answer to yet. I suspect that the very nature of the product, the fact that Blue is load and go, has meant that there hasn't been any work put into finding a way into it. But you don't really want people going in there and messing around with it. You want it to just be purely automatic. That may change in the future, but as a DBA, you probably want to know a little more about what's going on here. Now, it's not just me that's not been able to put a definite finger on what's going on here. I did actually get some help from some of the IBM guys in the Toronto lab, John Hornibrook, who's sitting here, and David Calmont, both took a look at this and made some suggestions and looked it over, but neither of them actually said, "Ah, you idiot, you left that out, that's what's wrong." So I don't think it's just that I put together a test scenario that's unrepresentative or doesn't work because of something I've done. So we haven't actually managed to come up with a smoking gun yet, but they have made a number of suggestions. So I just want to quickly run through those, if I may. How are we doing? So, as you mentioned earlier, what about making it purely columnar? What about converting the dimension tables to be column organized as well? Perhaps that would, perhaps that's the problem. Or one of the things that column organized data is specifically targeted at is subsets of columns. So if you remember, my contract table is only half a dozen columns, and I'm usually looking at 4 or 5 of those. It's not really a subset. So I put together a test where basically I just padded it out. Effectively what's happened there is I've denormalized it, so we've now got the dimension data in here as well, postcode, customer name, address, and then I put the contract down there, and I've just put in a whole load of extra columns, just to make sure that when I do run that exact same query, it's now looking at a subset of the data. And another suggestion, you remember what we said about the synopsis table at the start of this? Depending on the order you have when you load the synopsis table, you'll get a different set of values in there. So it may well be that I need to pre-sort the initial load so that the synopsis table is built in a way to address the queries that are going to access it. So I'm going to reload. I'm going to build another version of the table, and I'm going to load it with that order by there. So this aligns more exactly to the that that Q4 query we're running. So when I say Q5, Q6, Q7, what I'm doing is I'm just running that Q4 thing again, but with these different tables, different organisations, to see if that's going to actually improve things. So Q5, I'm just building both the dimension tables in the same way as I did before, as organised by column, and I'm loading it direct from the row-based version, so we now got the same structure, same data, it just happens to be column organised. And I'm going to run that same query, but just change the table names. Here's the results then. So there's the ones from before, there's the Q4 row-based and row-based with an index, and there's the Q4 column-based with the degradation in performance, if you like. That's the query I'm running. Q5, it's gone up to 65% in blue, but again, that seems a little low considering all the tables are now column organised. The estimate has got slightly worse, if anything, and the CPU has actually got much worse. Than the row-based with an index there. So if you look at the access path for, that's the Q4 access path, so you've got just the one column organised table, the CTQ boundary, the table scanner, the whole thing. If you compare it to this, it is all below, all the access is below the CTQ boundary. So presumably that other 35% is all involved in the sorts and group bys and so forth that are above that. That does seem like quite a lot. So that hasn't improved things yet. So we'll try the Q6 version, which is the same query, but it's against the contract table that's been completely denormalized and has now got extra columns. So we are now genuinely just choosing a subset of data. So there you go, the single table in the middle. And that's all the columns involved again. So the estimated cost has dropped from the column versions that we looked at before. The actual cost is slightly worse than the sort of vanilla Q4 that we originally had, much worse than Q5. We're looking at round about the same number of rows back from that table. Wait time's gone up. Again, I can't quite put my finger on that. Why it would be waiting more when it's only accessing all the data from a single table is unusual. Much more time spent in purely columnar, but that's what you'd expect. It is actually entirely column-based workload now. But go back to that index version of the row-based query, it's still way behind that. So let's try the Q7 one, see if that helped. This is where, if you remember it, we've reloaded the data into exactly the same structure we just had, so it's still got all the extra columns, it's still denormalized. I'm just choosing to load the data in an order that I think will help this query. And in fact, if you want to check it out, you can run a query against the synopsis table itself. You just kind of invert the where clause from your query and run it against the synopsis table directly. Obviously, there's a big chunk missing out in the middle because I've got 979 rows back from the synopsis table. That's out of a 4,800 odd that exists in here. Remember, you only get one row in the synopsis table for every 1,024 you've got in the base table. But it means that when you run the query, you've got to look at, well, what's that? That's almost 20% of the synopsis table. Maybe the synopsis table is excluded from that original access because it's just too big a result set. Once you've reloaded the data in the order that you want, you just get 7 rows back from the synopsis table for the same query. So that does look like it's more specifically configured to the query we're running. You will notice, however, that the postcode bit of it is pretty much useless as well. It's just got the full range in there again. So that's not going to help us there. So does that change the processing for the better? Well, the estimated cost is worse than for the previous execution and better than the Q4 and Q5 ones, but still a lot worse than the indexed version of the row. It's actually slightly better in terms of total CPU than the row-based version. I suspect this is something to do with the data skipping, because you've now got that much more compact set of data back from the synopsis table. It's more specifically configured to the query at hand. So there's a reduced number of rows read because data skipping is efficiently identifying just the slice that you need. It's got a higher rows read count than the indexed version, but the extra benefits of compressed data and the use of the CPMA indexes mean that the Q7 is slightly ahead in terms of CPU time. So there's a benefit there, but clearly you can't reload the base table and rebuild the synopsis table to service every query that comes in. It's got to be a generic choice. So yeah, there's another suggestion that was mentioned to me actually, and that Soma rose just now, was maybe the way you're looking at these metrics isn't as accurate, isn't as specific to column organised data as we'd like. Now I was in two minds about whether to put this query, this slide up here, because it does sort of confound my argument a bit, but I didn't think it was very professional or scientific to omit it just because it didn't fit in with my argument. So I'll run you through that. So what I'm doing here is I'm taking exactly the same set of SQL, and these are single executions, so with the same parameters embedded in the query, and just run through DB2 batch and comparing the total time. So pretty similar results for Q1. It's only using 12% of the row-based version, the best row-based version. Q2, again, similarly, yeah, brilliant, okay, Q3, that's pretty much what we saw before. So we run Q4, and it only uses 64%. So the column-based version, executed through DB2 batch, is actually better. And if you look at those experiments we just did there in Q5, Q6, Q7, yes, they're all better. So another thought I was doing some testing on something else, and I was having to do blocks of executions to try and determine the times for statements. So I've done the same thing with these. I've executed exactly the same queries, and I took a block of, I'm not sure if you're familiar, DB2 batch, you can execute blocks, and you can provide a parameter file that comes in and just runs against the same piece of SQL, so you get an aggregated figure for what it's like to run the same query 10 times or 20 times or whatever in a row. So the same set of parameters are being fired into the row-based version and into the column-based version. And again, I'm just looking at what happens there. So 10 repetitions, exactly the same. So the column-based version executed that many times is still 12% better than the best row-based version. Much better Q2, only 1%, only 3%. It's looking pretty good there. Q4. It only uses 5% of the best row-based version. Remember, this is comparing against the indexed one. Only 5% of the total execution time of the row-based version. Significantly better. The other experiments, again, very, very good figures. But I think that's largely irrelevant. And if you've got a column-based version with no effort that ran and used only 5% of the resource of your tuned row-based version, then you'd stick with that, wouldn't you? However, I don't think it entirely invalidates my argument, because in a situation where you have done a conversion, you have provided your client or your user with a column organised set of data, and one of them comes back to you and says, my report, my workload, whatever, is now running worse, what's going on? I don't think saying I've taken that SQL away and I've run it through a tool called DB2 batch 10 times and it looks better to me is going to be a career furthering statement, really, is it? They're not going to buy that. So we still have that issue. I can't explain that. I don't know why it looks better coming through DB2 batch, but That's really the point I'm trying to get at. There's something going on here, and it's quite hard to put your finger on this as a jobbing DBA. So,
Sorry to interrupt.
Yep.
Actually, this 10% or 4% is still not that good for glue, because for one of the customers we have seen, like, I mean, I think around 10 times or almost like 50%, 60% improvement. So still it matches with your earlier observation, like 4% for glue normally see dramatic improvement, isn't it? That's what I've seen myself. So
right, so the
4%, 10% is peanuts, isn't it?
well, the observation is that these figures, 5, 10, 4%, aren't really enough to justify blue acceleration. Remember, what that is that the column-based version has used 5% of the resource of the row-based version. So that is a significant improvement. If it's only using 5%, then it's actually streets ahead. Yeah. So that's, maybe it's down, I'm sorry, maybe I'm presenting the figures in a slightly confusing way there. What I meant was, it is just, if you look at the total time there, 0.18 compared to 3.38 for the row-based version, it's gone up a couple of gears. Right, well, in summary, I just wanted to say, as I said at the start, I don't want to knock 10.5 Blue. I think it's a phenomenal tool. I think it is quick and easy to use. I think column organised tables are a brilliant feature and one that needs to be explored. I'm just not quite so keen on the feeling that I've lost the ability to investigate and analyse performance issues. That said, this week I have found out a few things I didn't know before I came here. So if you do want to explore that further, I'd really strongly recommend looking at the presentation material from John Hornibrook and David Kalmack, who've actually got if you didn't get those presentations in the first place, there's a lot more that they've made available that I didn't realise was there. So have a look at that, have a look at sort spilling and hashing and stuff like that. And have a look at the ones that John's provided, because there's a lot more underneath the CTQ boundary that does appear in other situations. So, I think I'm almost down to about 5 minutes. Right, there we go. Okay, I'll call it a day there. If you've got any questions, I'm happy to have a go at them now. If anything occurs to you afterwards, by all means, use my contact details, drop me an email, and if I can answer it, I will. If I can't, then I'll go away and find somebody smarter than me to give us an answer. Yes, question?
You had that timer comparison.
Mm-hmm.
Have you checked, does it have any real-life value of if you compare to the run-through time, the actual execution time?
So the question is the figures I'm showing for estimated cost in timer-ons, does that have a comparison to actual execution time? Yeah. Well, the figures I'm getting back from the MonGet package cache statement are the actuals, but I think this is what we're getting at. There is a skew there. I can't see a direct correlation. So I think when you look at the estimated cost, the figures you're seeing are overly pessimistic for column organised tables. I don't think they bear a direct relation to the actuals, which of course does raise the question of what's happening with shadow tables and things like that. What is the optimizer doing? How is the optimizer deciding how to route things to row-based or column-based? Which one of those is it using? Yep, question?
One thing I noticed that between the raw queries with the index and the column ones, the join order changes. Have you tried forcing the join order using a profile of summit to see if that gives you a better performance? I wonder if the optimizer is just getting the join order wrong.
Right. So the question is that in the row-based queries, this is after I've applied extra indexes and yeah.
Slide 26 is a good example. It shows you the flip in join orders.
So when I'm experimenting with the row-based queries and I'm creating indexes, the join order is changing, and is that adversely, or is it that so the question is the column-based version, should that be subjected to the same join order in order to make an exact like-for-like comparison?
Yeah, so you see the comparison. Maybe it will not reveal that, but maybe it will show something else.
Okay. Well, the short answer is no, I haven't tried doing that. I'm coming away from this week with a whole list of things I have to try in order to try and explore this further. So I'll add that one in. So we'll have a go and see if we can construct a profile that does actually force the same join order there. Any other questions? No? Okay, in which case, thank you very much for your attention. I know it's been a long, hard week, so I do appreciate you all turning up here. Thanks very much and have a safe journey home.